So I will give you guys a 5-minute mask break to start off with. Okay, start timer. Cool. All right. We've been working on multiplying by one-digit numbers. We're taking one digit times like a bigger number, whether that has 2 digits or 3 digits or 4 digits, and trying to find the product, right? So factor times a factor gives us a product. Next week, we're going to get to the 2-digit numbers. So we go 2 digits times a 3-digit number or 4-digit. We'll get bigger. But right now, we're just dealing with that 1 digit times a 2-digit, 3-digit, or 4-digit number. Cody, did you have a question? Good question. I don't know if we get to those or not. We might. I don't know. I don't know how many digits we go up to. Not sure how many digits we go up to. But it's the same. Once you understand how to do it times like a 3 and a 4, like it's the same thing. It's just a more steps, but it's the same step, same process. Hmm? Yeah, you got the right idea. You're going to be breaking it down. Yeah, nice job. Like we call that generalizing is the fancy term. So like you're understanding how to do some of it, so you're making it into a bigger thing. You got it. So you got the right idea. So once you kind of understand these basics, we'll get you a little bit further. And you guys are doing a nice job. Like I said, you guys are doing a good job with this. I know it's a little confusing yet, but I think you guys are doing pretty well. We will take a quiz tomorrow. I looked at the quiz. I think you guys will be all right. It isn't asking you to solve a ton of multiplication problems. There's a couple of them where it's like, here's a problem, fill in a couple numbers on it, right? They started it, you just got to finish it. So there's that kind of questions on it. Or is, which of these would help you get the answer? So there's that kind of stuff. So it isn't so much actually solving as understanding the steps to it. Raina? Okay, maybe. Could work. And we'll talk about that. The other thing I'm just going to remind you too is that estimating thing is going to keep coming up. So just kind of think about those and hopefully we're getting there. But real quick, you can pull out your iPads, go to notes or show me some sort of blank sheet. And do a couple practice ones here first. Hey, solve this problem. Solve this and then draw a picture. I need a noun and a verb. Noun and a verb. Somebody raise their hand and give me a noun and a verb. Tucker, you raise your hand quick. Flying dragon. There we go. Answer this. Draw a picture of a flying dragon. Hopefully you guys got it. Let's take a look at this one. Just flip your iPads down for a second. I know you got your flying dragons going. Just flip them down for a second. There's the timer. Mass up. So let's take a look here. Who wants to share like one way they did it? Like Mr. S is how I got the answer. And you can glance at your iPad real quick if you need to, but hopefully keep them down flat. What do you got? Share with me one way. Cody, what'd you do? So you had 30 times 6, and that gives you, so 3 times 6 gives us 18, add 1 0. Again, I like to do the lines underneath, so 3 times 6 gives me 18. I'm going to add 1 0 here. And nice job, so it's 180. And you did 4 times 6, which gives you 24. And then you just add these up. And you got this. Okay, that works. How many did this? Okay, a bunch of you. And you might have wrote it out a little differently than I did too. There's different ways. What we call, there's a few different methods to this. And you also could have written it pretty much the same way and done. So if we go 34 times 6 in the book, they've showed you this. And so they would have written it out as, you're going 6 times 4. So you got 24, 6 times 3, which gives you 180. and you would have done it this way, but you would have got the same answer, right? Okay? I mean, how many of you did one of those two? Something like that? They may do a different way. This works fine. That's great. Good. Boz, what'd you do? Did you do lattice method? Okay. We'll get to lattice. I haven't gotten to that yet. Oh, yeah. You would have done it. Yeah. We'll get to lattice. We'll get to lattice eventually. Um, that would be, so what Boz is talking about is you did, let's see here. So you did this. You did this. 3 times 6 is 18. 4 times 6 is 24. That's what Boz did. It's a weird method. I'm going to show you this to you eventually. But actually, this works out. If you look at what Boz did here, I'll get to this. This is kind of a quick introduction to lattice. You'll notice what you do is you end up adding on the diagonals here. So here she's going 4 plus nothing. Well, look, here's 4 plus 0. Here's 2 plus 8, which gives you 0, carry the 1. Here's 2 plus 8, which gives you 0, carry the 1. Here's the extra 1 plus 1. Here's the extra 1 plus 1, right? So you end up getting, it's kind of a weird way to do it, and I'll show you guys this more later, but it's worth showing you right now that you're basically doing the same things. It just looks different. It's a little different, and I'll get to showing you. The reason I don't show you this first is this might be easy, but it doesn't tell you why you get any of these numbers, right? It's just kind of what we call an algorithm. Like you get the right answer, but it doesn't really break it down. Here you have to understand that you're going 6 times 4 and 6 times 30. You have to be able to understand all the parts to it. But you got it. Anybody do it a different way? Raina. So you went 4 times 6 and then. Oh, okay. Okay, okay, yeah. Either way, and when you multiply, is 2 times 4 the same as 4 times 2? Yeah, like it doesn't matter the order, right? So whenever you switch those around, that's fine. That's true for adding also. It's not true for subtracting. It's not true for dividing. But when you're adding or multiplying, it doesn't matter the order. Yeah. Oh, so did you? Okay. I think what you're saying, tell me if I'm wrong. You did 34 times 3. So, like, did you do 34 plus 34 plus 34? So you got, this would be a 2, carry the 1, 4, 5, 6, 7, 8, 9, 10. So you got this. And then you doubled that. Yeah, that works. I like that. That's a good line of thinking there, David. I like that. So to kind of summarize what David did there, that works, right? Kind of like our forest trick, you can double it and double it again. He took that, applied it to the threes. So instead of going 34 plus 34, he did 34 plus 34 plus 34. So he did it 3 times. So if you know what 34 times 3 is, you should be able to know what 34 times 6 is, right? If you know what 34 times 3 is, 34 times 6 would be twice as much. Yeah. And to kind of carry on with this idea, if you knew that 204 is 34 times 6, how many could tell me what 34 times 12 is? If you know what 34 times 6 is, can anybody tell me what 34 times 12 is? If you know what 34 times 6, you might know what 34 times 12 is. What do you think, Scarlett? Yeah, it'd be 408. Look at that. Scarlett, you did that in your head. You just did 34 times 12 in your head, Scarlett. Right? Kind because she knew that it's going to be twice as much as 204. So she just did 204 plus 204, I'm assuming, right? Or did it just magically come to your head? Yeah, you did the 204 plus 204. Yeah, so that's a good thought. I like that. Nice job. Cody? Oh, okay, good. Maybe. Cool. Here's what I want. I'm going to give you guys another problem. I want you to find somebody in the room without talking, point at that person, all right? So that you're each pointing at each other. That's the person you're racing. It's going to be a race. We've done this before. First person with it done correctly, find a person so you're each pointing at each other. Does anybody not have a partner? Raise your hand if you don't have a partner yet. Everybody know who they're racing? All right, perfect. You two. Jovina, you need a partner? No, never mind. It's not working. Close the app and reopen it. All right. I'm going to give you a problem. Solve it. Oh, real quick before I do that. We didn't cover 34. We didn't cover area model. 34 and 6. So I'm going to cut this up here. This is 30. This is 4. Right? So I know the area of this blue box is going to be 6 times 30, which would be 180. I know the area of the green box, 6 times 4 is going to be 24. 180 and 24. I kind of did. Yeah. 204. But either way, do you see how the same thing is happening? 0 plus 4. Here I've got a 0 plus 4. Here I've got a 0 plus 4. Here I've got a 4 plus nothing. All of them are basically doing the same thing, just in a different way. Yeah. We'll find out. Who needs a partner? Oh, when I asked who needs a partner, all right. David, Smothers, who's your partner? All right, you group of 3. Here we go. Here's the problem. Go. The same thing I did for her. Okay, even if you're not done, flip it down just so all your iPads are down. 124 times 5. There's lots of ways we could have done this. I'll start with the area model one, just because that's kind of my personal favorite one. So if I do an area model, what would I break this up to? Anybody want to walk up to the board and kind of tell me how I draw my lines and where I break this up to? Everybody should have your iPads flipped down. Rissa, you get your iPad flipped down. Why don't you go up there and do that? Okay, somewhere in here. Maybe over here somewhere. Okay. All right. And so what am I going to call these then? Yeah? Yeah, Rissa. 4. Yeah. Good. And again, I kind of color code these real quick for you. So I'll give you a blue box, green, yellow. Okay. What's the area of the blue box? Cody. What's the area of the green box? Let's see here. Mayaski. What's the area of the green box? 5 times 2 is 10. Add a 0. 100. What's the area of the yellow box? David. What's 5 times 4? Okay. Nice and easy. Easy addition. Man, this is easy addition. Should have gotten 0 to 6. How many got 620? Cool. All right, let's try one more. Okay. Hey, show your partner. Raise your hand Oh, wait, listen. Raise your hand if you were the first person done with it correct. First one with it done correct. So if you got it wrong, it wasn't you. First person done with it correct, raise your hand. Cool. David, you didn't finish the question, so I don't think you were the first one with it done correct. Okay. So if you have your hand raised, find another partner with your hand raised. Point to that person. Well, you two, right there. Perfect. You two. Okay. If you need a partner, raise your hand. Find somebody else. Make a partner. Okay. Cool. Perfect. Madeline, David, you guys are partners. Ready? Here you go. Next one. And that one. Nope. It's gonna be one group of three. Go. What's 9 times 1,000? 248. Go. Let's turn in your math drill back to page 247. No, my bad. Yeah, 240. Is this the one that I left? Is this the problem I left you guys with? Yeah. So page 247 here. This is the one I wanted you guys to do, right? All right, okay. So we're done. Cool. Taking a look at page 247. Two different ways to do this. We got lots of different ways we can solve most of these problems. Area models, or you could do it a few different ways. I think a lot of you, how many of you wrote it out like this way? So you went 435 times 2, and then you're going, so you did 2 times 5, and then you did 2 times 30, and then you did 2 times 400. So this would be, so 2 times 5 is 10, 2 times 30 is 60, 2 times 400 is 800. You would add something like this. Anybody else have 870?
Yes. Wait, is it a math break?
Yes, it is a math break. I'll set the timer.
Oh, yeah.
I'll set the timer right now. You can take the mask off and math break. Good. Now you could have done this different ways, but you guys got kind of the idea. Again, if you did it wrong, take a look back, like see how you did it to try to get the correct answer, right? And you can do those. And yes, I know, again, you could have done repeated addition, and some of you chose to do that. You're getting there. It's just, it ends up being a lot of extra steps, and it's going to be really hard when you get two bigger numbers. Okay, so it'll get you there. So that was number 2. Or sorry, number 1. Number 2, I need an estimate. Okay, so we're going to solve, we're also going to estimate it. I'm just going to estimate it first instead.
Just estimate?
That's what this word is. So what would be close, and it doesn't have to be that close, we just want to get a nice round, easy number. What would be a much easier number to work with instead of 6,309? What would be a much easier number to work with? What do you think, Mayaski? Yeah, I would just go straight to 6,000. Would 7,000 be a good option?
No.
Nah, because you wouldn't round it up, right? The 3 is going to tell the 6 to stay the same. And so you're going to want to go keep it down. And so let's go, which 4 times 6,000 should be a nice, easy problem, right? What is 4 times 6? Somebody help me out. What's 4 times 6? Think about it. 1, 2, 3.
24.
Add 1, 2, 3 zeros. There you go. So is that my answer? No, but it should be close to that. It's going to be around there. All right. I'll do this one. I like my area model one. It's up to you. You don't have to do it area model. You probably did it. If you did it differently, it's okay. You don't have to do it area model. I'm going to find the actual answer right now. So here's my thousands, hundreds, tens. Here we go. So I've got my 4, and I'm going to go with 6,300. This is going to be a 0, I guess, and 9. Could I have left this one out? Yeah, there's actually nothing there. It's 0. How many of you went 4 times 0 and wrote down 4?
I didn't.
Anybody? It's okay if you did. That's not right, though. 4 times 1 is 4. All right, so we're going to be adding 0 here. Let's see. We already did this one. This is 24. Add 3 zeros. This is 12. Add 2 zeros. And this is 4 times 9 is 36. And all of this, again, is on page 248.
Yeah, you can't really see it.
Can't really see that.
Thing is-
248.
Okay, that's
A little better.
even harder. It's worse. No, it's not.
So now we just got to add these up. Again, when you add these up, guys, it's really important that you keep your ones columns aligned. I don't have to really add the 0 if I don't want to. I'm just going to go straight to 36. But this is a super easy addition problem, right? Right here. Makes this super easy, and you could have done this several different ways.
Oh.
How many of you got something close to that?
I got that exact answer.
Hopefully. Again, if you get it wrong, guys, it's okay. It's okay if you got the wrong answer. But hey, is my answer close? I'm going to say I'm getting close, right? It's a little bit off, but I'm close. That's all right. But somewhere in your answer, however you did it, you probably should have had a 24,000. You should have had a 1,200. You should have had a 36.
Yes.
So just kind of look at those. If you made a mistake, it's all right. It's not the end of the world. I want you guys, we're going to skip ahead. I want to skip to number 4 because this is pretty important. So we're skipping ahead to number 4. There's your mass break timer. I'm going to give you a second here. If you didn't get to it, it's okay. Take a look at number 4. And this is on page 249. Take a look at number 4. It says select the expressions that have a product of 810. Select all the expressions that have a product of 810. Is there going to be more than one? Yeah. There can be, I shouldn't say there will be. There can be, right? So it's all the expressions. So take a look at these. I'll give you a second to work on it. I'll give you a hint. The only real way to do this is to solve them. Okay? So then we'll start solving the ones that are up there. Some of these should be easier than others, but give it a shot. You're looking at number 4 right now. We're looking at number 4 right now. So show your work, though. Show your work. So I don't know. I mean, some of these are wrong. Just tell me that right now. I would look back through to show your work. Because on your quiz, you're definitely going to want to show your work. Yeah. Hey, let's take a look at number 4 here. Some of these you can do in your head, right? Or it shouldn't be too bad. If I'm looking at doing 90 times 9, what's 90 times 9? It's just 9 times 9, which is 18. Add a 0, or sorry, 81. Sorry, 81. Add a 0. Okay. This one, A repeated addition one would be easy for this one. So you could do 405 plus 405 and just add them.
That would equal
810. This one, 3 times 2 is 6, add a 0. 3 times 7 is 21, add a 0. So now I'm going 60 plus 210. 2, okay. Here I'm going 2 times 2 is, 2 times 4 is 8, 2 zeros. 2 times 5 is 10. That should be 810. This is 500 plus 5 times 60, 300 plus 5 times 10 is 10. So looking at this, so this would be 500 plus 300 plus 10 would be 810. So I've got an 810. There's an 810. There's an 810. This one is not. This one is. This one is. So you should add all of them except for C. Now, again, the only way you're going to get that is by actually doing it. Last one I really need you to look at because there's one just for quiz tomorrow. If you haven't done it yet, turn to number 7. Did I make a mistake, Jenna?
Which one?
You added 9 plus 9, not multiplied. 9 times 9 is 81. I did the same mistake. Take a look at number 7. Give this one a shot. I'm telling you right now, there's one just like this on your quiz tomorrow.
How do I not see any numbers?
I'm going to help you out. I'm going to read it. I'm going to talk you through it. I'm telling you one right now, there's one just like this on your quiz. Once I explain it, it won't be as bad. It says, Laura says, when you multiply a 3-digit number by a 1-digit number, that's how Laura sounds. The product is always a 4-digit number. So then Laura writes an equation to show she's right. Greg says, no, Laura, you're wrong. And Greg writes an equation to show that Laura is wrong. And then he throws it in her face and says, see, you're wrong. Okay? Greg is putting her in her place.
Greg's right. Greg.
Now, complete the equation to show. Now, there's lots of different ways we can do this. Okay? Now, again, what Laura is saying is if you go 328 times a number, you're always going to get a 4-digit number, no matter what. So right now you can put in 4 digits here. 1, 2, 3, 4. Laura says you're going to get a 4-digit number no matter what. That's what's going to happen as long as you have a 1-digit number here. You're always going to get a 4-digit number. Greg says, no, you're wrong.
Greg's right.
Okay? And Greg says there's a way to do it times a 1-digit number, and get something that doesn't have 4. Okay? So what numbers could you put in here to show, yep, if you do, there is a way to get a 4-digit number here. So put in one number here to show a 4-digit response. And then put something put a 1-digit here to get something other than 4. I'll give you a hint. I would probably do this to show you could get a 3-digit number. Okay. So give this a shot. I get it. It's hard. It's kind of weird and confusing. Okay, I'm trying to help you out with the lines here. Laura says if you go 328 times a 1-digit number, you'll always get a 4-digit number. Show how you could do that. Then, show how you can go 328 times a number and get a 3-digit number. Go. Give it a shot.
I already did it.
Yes.
I already did it. That'd be correct.
This one is, but you got to show me a 4-digit number. This one's fine. Yes. Let's try.
Mr. Jingle bells, jingle bells.
That's how exactly what I'm looking for. Yeah. 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 You didn't actually sell them, you estimated it. But these are good. Yeah. Here, let me talk you through this one. For Greg's, if I wanted to get a 3-digit number, and some of you did this, the easiest way, what I would do to make the work really easy on me, is what could I multiply times 328? What's one number to get a 3-digit number? You could do 2. I was just going to do a 1, just because I know what 328 times 1 is without doing any math. I would have just done 1. 2 works also, and 3 would also work, actually. 3 would work. I'd just do 1.
I thought you were color coding the numbers with the bottom.
328. Because 1 times... So that's how Greg could show his answer. A 2 or a 3 would also work. I'm just trying to keep the math simple. And anything over 3 would work for this. So if you did a 4, that would work. So 328 times 4. Let's see here. This would be 8 times 4 is 32, 80, and 3 times, so 120. No, 1,200. So you would add something like this.
How does that work, but 5 doesn't work?
5 would work.
No.
8, 9, 10, 11.
Wait, for the lattice method?
There you go.
For the lattice method? Lattice method, whatever you call it?
Lattice, like this.
Yeah, so if you get like 32 for 1, then do...
You carry it.
You carry it?
Yeah. So lattice would be 328 times 4. So this would be 32, 0, 8. And then this would be 12, 2. This would be 11, carry the 1, 3, 1, 1, 3. Here you go. So either way, however you got it. Okay, I'm going to stop right there. Miss Anderson's here. So, go to wherever it is you went yesterday for Bayside. What was the question?